Welcome back. In Section 5, we'll talk about some expert Scala tricks that you can use in certain cases to really deal with some annoying or difficult or useful situations. We'll start by talking about advanced string interpolation and devising your own interpolation strategy when that's the thing that makes sense. Then we'll talk about using try and either for representing type alternatives. We'll talk about parallel collections and how they can help performance in certain cases. And finally, we'll talk about parametrized types and generic programming. Let's start with advanced string interpolation. First, we'll talk about custom interpolators in general, and devise a somewhat complicated one of our own, and then we'll talk about some examples in the wild, and in particular how we can use interpolators with Scala XML. Let's get started. First, let's talk about what we want this interpolator to look like. We'll devise a fold interpolator that can process a string like this, where add and multiply are functions that take two integers and produce an integer, and make it so that this string, quote-unquote, is processed to produce an integer. If we try to run this now, we'll see first that we get an error that fold is not a member of string context, and then that we get an error that add and multiply don't exist. Let's start by defining add and multiply. These are very simple anonymous functions. They take two ints, add adds the two ints, multiply multiplies the two ints. Then let's create a very simple version of the fold interpolator. So we define an implicit class, fold interpolator. It takes a string context, it extends anyval, which makes it a value class, and then we define the fold function on it. And it takes a set of parameters. Now, to start with, we're going to do two things. We're going to return the parts and the parameters that are received. This is a way for us to have a deep look at what the fold interpolator actually gets. So if we run this again, we'll see that the parts that the string context gets are 1, 2, 3, and 5 strings with spaces in them. And the parameters that are received are the three functions, add, and multiply, that are interpolated in. So first off, we'll want to make sure that all of our past numbers are in fact numbers. So we're going to go ahead and say val ints and parse all of our ints. So we'll take the parts, trim them, and convert them to ints. Then we'll return that, as well as our original parameters. Let's try running fold again. This time we get an array buffer of our ints, and we get the three functions. So the next question is, how do we apply these functions? So we'll start by trying to apply them the naive way. We want to take the first two integers and apply the middle function to those two. And then we want to take the result of this and apply this function to that and this guy. So let's start just by adding these two. Let's start by taking parameters, the first parameter, and applying it to the first integer and the second integer. And let's see what we get. Now you see here we get that apply is not a member of any. Parameters here is just a list of any, so we don't know the type of the parameters that are passed. To deal with that, we're going to use a collect to unpack our parameters into real functions. We'll start by creating a new variable that's basically our operators. Then we'll go through our parameters and we will collect the ones that are binary operators, which are function twos. That's functions that take two parameters and return one. Now in the pattern match, we can't match against the type here, because type erasure means that we don't have the type. We'll talk about that a little bit more when we talk about generics later. However, we can force the type and say this is definitely something that takes 2 ints and returns an int. Then we can try ops0.apply ints0 ints1. Now if we see here, our binary operator is now trying to be converted to the wrong thing. We fix that. There we go. Let's try this again. Now we get 3, which is the result of adding these 3. The question is, how do we make this work for arbitrarily many? So once we've done the first 2, we can start accumulating the rest. So we drop the first operation and we zip it with the remainder of the integers. And then we fold left and we start at the result of this initial operation. Then what we're getting here is the latest value, the latest integer, and a tuple of our operation and our next int. So all we have to do now is apply the operator to the latest and the next int. Notice that we're not really respecting order of operations here. Let's try running this. Here we get 30, which is what we'd expect. 1 plus 2 is 3, plus 3 is 6, times 5 is 30. Again, we're not respecting order of operations, otherwise we would have done 3 times 5 is 15, and then 1 plus 2 plus 15. Let's see if this extends arbitrarily. 12 multiply 153. Oops. We get error messages whenever we misspell things. So because this is an interpolation, it does try to look up what this operator is. That works. What happens if we leave something off here? We get a number format exception because we've tried to parse the blank string that comes after add as an int. This isn't ideal, and we could add some error handling up here to make this error message better. What happens, on the other hand, if we end up with fewer operators than we expect? Now we get an index out of bounds exception because we try to do an ops 0, and there is no 0th op. So we get an index out of bounds exception. Again, we could do a little bit of error checking, make sure that there's at least one parameter so that we don't error out like this. However, we've created ourselves an interpolator. This is a fold interpolator, and it gets applied to a string, but the result is always an int. This is a very, very powerful thing. It means that we can take arbitrary strings and represent them, or use them to represent complex situations. Another great example of this is with XML. So let's import the Scala XML module. The Scala XML module gives us some easy ways to parse XML. We'll go ahead and import it for the 2.12 Scala release. Let's say that I wanted to define another interpolator, but this time we'll call it the XML interpolator. And we will call this XML, and we're going to start from scratch on the body of the function. So this XML interpolator, we're going to start by by taking all of our strings and gluing them together. So we take the parts and we zip them with our parameters, and then we go through and we turn them, or flatten them basically, into single strings. So one big string that has the part followed by the interpolated parameter, followed by the next part, followed by the interpolated parameter. So we're going to go through this and say, okay, we'll collect and we'll go through the various possibilities. So really, each parameter can be blank, or it can be absent. Now what happens with zip is we'll only get one entry if sc.parts has a corresponding entry in parameters. So let's start by just saying we want to take the part and the param, and we want part plus param.toString, And then once we're done collecting these, we make string. So we just combine them all into one big string. So first off, let's see what happens if I say ABC here. I get an empty string. And that's because there are no parameters. So parameters is empty, so zip doesn't do anything. I can fix this by using zip all, providing a default in case either side doesn't have an entry. Now we get ABC. Now, keep in mind that the interpolated item can be anything. So I can do here 5. I can do hello.split by E. Let's see what that looks like. So here we've two-stringed the result of this split. And if we turn it into a list, we'd get a prettier string. But fundamentally, we're taking everything and turning it into a string. And then we do one last thing, which is we say XML. Well, we'll assign this string, val whole string, in here. And then at the end, we'll return the result of xml.loadString whole string. And actually, this lives in Scala.xml. So Scala.xml.xml. Now, if you see here, we immediately get an error because this isn't valid XML. We need a root tag. So let's wrap this all in a div tag. Now, we get an actual XML data type, which is a div element that contains some text. And if I invoke .text on it, which is the XML function to fetch the text within, I get this. Now, another interesting thing that happens is if I had a contained thing here that is XML, I would see a first-class XML element, and inside it, B is also a first-class XML element. So if I take res26.child, which returns all the children, I would see a whole lot of nodes that live within it that handle the various details that we've created by creating this parse tree up here. So this is really the kind of stuff that you can do with string interpolators. We've done it with XML, and in fact there's work to make this how XML is handled in Scala as part of the XML library that's ongoing right now. And we've seen how to do some fairly basic parsing as well. You can also do this stuff with a macro, which means that you can do it at compile time and make sure that the string that's being passed in is actually valid before you compile the application. That's it for string interpolation.